Hi students, welcome to our physics class. In this class, we are going to discuss the topic is electricity. Subtopic is resistance of the cell. Resistance of the cell we are going to find. Yes, how to find? See, before going to that, we study about the cell. See here, cell, this is the structure of cell. This is outside circuit. This is cell. Outside circuit consists some resistance. Outside circuit which is connected to the cell, the circuit has some resistance. And here inside the cell there is a resistance in the chemical. What is resistance? Already we discussed. Obstruction. Obstruction to the flow of current. See, as per the nature of the circuit, metal of the conductor, as per the nature of the metal of the conductor, there may be some resistance in the circuit which is connected to the cell. Inside the cell, because of chemicals, there may be some resistance inside the cell as per the nature of the chemical. Here, now we are going to find the resistance of this cell. Resistance means obstruction inside the cell. We are finding. How to find? Look at here. You know total resistance of the circuit. Total resistance in the total circuit. Inside the battery, inside the cell, and outside the cell, which is connected to the terminal. So capital R plus small r. We know as per Ohm's law, V is equal to IR. V is equal to IR. Here see, as per Ohm's law, outside potential difference V is equal to IR. As per Ohm's law, V is equal to IR. That potential difference inside the cell, V is equal to small v is equal to I small r. Inside the cell, I small r. Outside the cell, circuit potential difference is equal to I capital R. You know potential difference means energy supplied to carry the charge. Required energy to carry the charge. Outside the terminal, inside the battery we are finding differently. Outside terminal means outside circuit which is connected to the circuit, which is connected to the cell. That outside circuit has some resistance. Because of the resistance, outside potential difference is equal to V is equal to IR as per Ohm's law. Inside cell, the potential difference is equal to V is equal to I small r. Here resistance of the cell chemical is small r, resistance of the circuit is capital R. So I is same. The total circuit flow of current is same. I will not change. So I capital R for outside potential difference, inside potential difference I small r. Now you know, in previous class we studied, we learned epsilon, total EMF is combination of potential difference outside and inside the cell. That means potential difference in the circuit, outside circuit, and potential difference in the inside cell. So here the total is combination gives the total EMF, electromotive force, means total potential difference along the total circuit is equal to small capital V plus small v. We know as per Ohm's law, V is equal to IR, V is equal to IR. So capital V is equal to I into capital R plus small v means I into small r. Now here I is common. I same. I will not change. Throughout the circuit current is same. I common. Then we will get R plus small r. That gives formula for total EMF. There is another formula we got. What is the first formula to find total EMF along the circuit? Capital V plus small v. Here another formula we got from this derivation. Total EMF is equal to I into capital R plus small r, where capital R is outside resistance, small r is inside the cell resistance. So I into capital R plus small r gives total electromotive force of the total circuit. So we got another formula. Now resistance in the circuit, resistance in the cell, we can find out. That is resistance in the cell R. Yes, we can find out. R is equal to small r, we can find out E minus epsilon minus I capital R. E minus I capital R is equal to I small r. Now small r is equal to E minus I capital R by I. So then we will get small r. Now this gives the resistance inside the cell. Bigger. We can use this formula to find resistance inside the cell. Total EMF minus I into capital R by I. I means current, R means the resistance outside the circuit. Resistance of the outside circuit which is connected to the cell. Now this is the resistance of the outside circuit, and current I. EMF total, EMF along the total electromotive force along the total circuit means total potential difference. Okay, now E minus IR by I. This is one formula. We can modify this formula. E minus, as per Ohm's law, IR is equal to V. Now as per Ohm's law, IR is equal to V now. Now I means V by R. In the place of I, V by R. So if you simplify, E minus V by R. I means V by R. IR is equal to V. Modified as per Ohm's law. Now here see, if you simplify, what will get? E minus V by V into this denominator comes to numerator as per fractions. By fraction into inverse, reciprocal fraction R by V. So R multiplies, simplification. Now E minus V into R by V. Now we can modify this also. E by V minus V by V means 1. So this denominator is common for both. E minus E by V by minus V by V minus V by V into R. So E by V minus V by V 1 into capital. This is another formula to find resistance. Here epsilon total EMF by V means capital V means what? The potential difference of the circuit minus 1 into capital R means resistance of the outside circuit. So here why the difference? Why this formula is one? Why we are using this formula, another formula? What is the necessity of writing another two formulas? Here see, as per given, we can find out as per given values. We can choose the formula to find the resistance, inner resistance of the cell. When EMF is given, current is given, resistance of the outside circuit is given. This is the formula. When EMF is given, potential difference is given, and resistance of the outside circuit is given. This is the formula. Here no I, current option, only potential difference. Here potential difference option, current is given. So as per given values, we use different formulas to find resistance. Okay, this is simple once you practice. Thank you.